So welcome back, Stella. We're going to do the next exercise. Yes, I'll do this one. You have to do this other one as assignment. I hope you did it already. So try to do it. I'll be waiting for your solutions. So the next one we have to solve is cos 2x being equals to cos of 2x minus pi on 6. So cos 2x equals to minus cos of 2x minus pi on 6. So where is it? Let's go to, so let's create another sheet of paper. This is page 11. I create another one, 12. Okay. So we are to solve, where is it? The B part, exercise 2. Cos 2x equals to minus cos 2x minus pi on 6. The B part, cos 2x being equals to minus cos 2x minus pi on 6. Is that okay? Okay, let's proceed with this question. We see that there is already cos here and there is cos here. Our problem will be this minus. If this was sine, I will just bring that minus inside because I know that sine of minus x is equals to sine is equals to minus sine x. Is that okay? But the problem is that this is cos. We cannot bring that minus inside because we know that cos of minus x is equals to cos x. Is that okay? So here are some important rules I'm going to give to you. Some important identities that I'm going to give to you. You have to remember them very well. Remember them. We know that the sign of pi minus x. Pi minus x, we have to find this the cos of pi minus x and the sine of pi plus x and the cos of this is x, pi plus x. Okay, what does this always gives? You can develop this using expansion formulas. You get what I'm saying, but it's easy, it's very easy to know this. Pi, if let's assume x is an angle in the first quadrant. If x, let's take for example, this is a quadrant. If x is an angle in the first quadrant, it means that this angle, if this is x, what is this angle? This angle is pi minus x. Is that okay? This angle is pi minus x. It means that this angle falls in which quadrant? In the second quadrant. We can, yes, it means that this angle is like an angle in the second quadrant. Is that okay? So if I look at this as an angle in the second quadrant, where is sine? You can remember that if I write sa terminal c, sine is positive in the first and in the second quadrant. So it simply means that the sine of this is simply equals to sine x. Is that okay? The sine of this is equals to sine x. I hope you understood my reasoning. This is an angle of the second quadrant. And how is the sine of an angle of the second quadrant? It is positive. So I'll have this is equals to sine x. Is that okay? Now, this is still an angle of the second quadrant. How is cos in the second quadrant? Cos is negative, so this is equals to minus cos x. That's how you can remember it. Pi plus x. If when you draw the quadrants like this, this is already pi. If you are to add an angle x, it means that you're already where? You're already in the third quadrant. You're already in the third quadrant. Is that okay? So this is an angle in the third quadrant. How is sine in the third quadrant? Sine is negative, so this is minus sine x. Do you understand what I'm saying? The next thing for cos. The next thing for cos. Pi plus x is an angle found in the third quadrant. So cos of pi plus x will be equals to minus cos x. So what you can remember is what? The cos of pi minus x is always minus cos x, and the cos of pi plus x is always what? Minus cos x. You get what I'm saying? So I hope you understood the reasoning, how I reasoned to bring out these identities. They are very important identities you have to remember. They are very important. You should not cram them. You should understand this is sine. You should understand the logic behind it. You get what I'm saying? Okay, now let's try to solve this. One of these is going to help us to bring this minus inside. So this implies cos of 2x will be equals to what? Look at something. We know that the cos of pi plus x must be equals to minus cos x. So if this is minus, you can decide to use this one, you can decide to use this one, because these two ones have minus cos outside. You get what I'm saying? But I'm going to use, for this case, I'm going to use plus. I'm going to use this plus. You can decide to use this minus. You get what I'm saying? So this x will be assimilated to what? All what is inside here. And you see that there is this minus here. So what I'm going to write is that I'll first write this. Recall that cos of pi plus theta must be equals to what? Minus cos theta. Is that okay? So this implies minus cos 2x minus pi on 6 will be equals to what? This is my theta. So this will be equals to cos of pi plus this theta, according to the identity, plus this 2x minus pi on 6. Is that okay? So it implies our minus cos 2x minus pi on 6 is equals to what? Pi minus pi on 6. This is 5 pi on 6. So I'll have cos 2x plus 5 pi on 6. Now I'll just substitute this by this where I see it. So this implies we're going to have cos 2x being equals to what? Cos 2x plus 5 pi on 6. Is that okay? So let's now proceed. Let's continue. Now we're already in the form cos. We're already in the form cos y being equals to cos x. So we can already apply the general solution. Don't forget that we are finding the solution on the interval minus pi. So the step 1 is to find what? The general solution. But first start by finding the general solution before finding the solution on this interval. So the general solution, of course, this implies, or it's implied by what? 2x would be equals to what? This 2x plus 5 pi on the 6 plus 2k pi, or 2x will be equals to what? Minus of all this, minus 2x plus 5 pi on 6. This is 5 pi on 6 plus 2k pi, where k belongs to the set of integers. Never forget that. And don't forget also your all. So this implies, or it implied by, this and this will go. So I'll have 0 being equals to 5 pi on 6 plus 2k pi, which is impossible. So this first one does not have a solution. 0 cannot be equals to this. That's impossible, because these are numbers. So this one has no solution. So the next one, or x, look at something, there is a minus here. When this comes like this, I will have 4x being equals to what? 4x being equals to minus 5 pi on 6 plus 2k pi with k belonging to the set of integers. You get what I'm saying? Okay. Let me first remind something. When we were solving this question, look at something. I told you something about this minus, that the minus here, there is no need of leaving this minus, because this integer, this is already an integer. It will be an integer which is a positive and a negative. Integers are positive and negative whole numbers. So that's why I changed the minus here, and here to plus. But look at something. You can decide to leave your answer like this. It's not wrong. You can decide to leave your answer, that is your general solution here. Your general solution here can still be pi on 6 minus k pi on 2, comma, pi on 6 minus k pi. Your general solution can be that. You will work with that to find the solutions on these intervals. You are still going to have the same answers. So take note of that. My only aim was that I just wanted you to understand that there is no, because in multiple choice, they can give you this. They can give you the general solution with this, or they can give you the general solutions with this minus. You should understand that you are going to have the same answers. So understand the logic behind things. So let's come back to our exercise. So from here, this implies, or it's implied, right? There's no need of continuing with this, because this is impossible. There will be no solution here. So we are going to have x being equals to, I will divide all through by 4. So I will have here minus 5 pi on the 24. So I'll have minus, when you divide all through by 4 here, the 4 will be under here. I'll have minus 5 pi on 24 plus, I'll have 2 on 4. That will give me a half. So plus k pi on 2, where k belongs to the set of integers. So the general solution, so the general solution, s will be equals to what? Any number of this form, minus 5 pi on 24 plus k pi on the 2 with k belonging to what? The set of integers. Is that okay? If you are to give it in terms of degrees, you just replace this pi by what? 180 degrees. So you have minus 5 times 180 degrees divided by 24. Is that okay? Plus this will be 180 degrees divided by what? 180 degrees divided by 2, which is what? 90. So you have 90 degrees times k. Is that okay? Okay, now we have the we have the general solution. Now, after finding the general solution, the next step is to find what? Finding the values of k for which we have solutions on the interval minus pi. Very good. So that's what we're supposed to do now. Okay, recall. No, we first need to, okay, there's only this one we have to do. For x being equals to what? Minus 5 pi on the 24 plus k pi on the 2. Is that okay? Where k belongs to the set of integers. Okay. Already recall that x belongs to what? Minus pi. That is, what does it mean? It means that x must be strictly greater than minus pi, but less than or equals to what? Pi. Is that okay? Our x here is this. So we substitute, when we see x, we will substitute by this. So this implies minus 5 pi on 24 plus k pi on 2 will be strictly greater than minus pi, but less than or equals to what? Pi. Okay, we have pi everywhere. We divide all through by pi. So this implies I'm going to have, when I divide all through by pi, I will have minus 5 on 24 plus k on 2 strictly greater than minus 1 but less than or equals to 1. The inequality sign is not changed because I divided by a positive number. So let's continue. Now, I need to add on both sides, I need to add 5 on 24 on each part of the inequality to remove it from here. So I'll have minus 1 plus 5 on 24. Here I'll have minus 5 on 24 plus k on 2 plus 5 on 24 less than or equals to 1 plus 5 on 24. Is that okay? Very good. Now, here I'm going to have, this will give minus 24 plus 5. I'll have, I think it's minus 19. I think with minus 24 plus 5. If I 24 minus 5, that's 19. Yes. So I'll have minus 19. So here I'll have, first of all, this and this will go. I'll have k on 2 strictly greater than minus 19 on the 24. Yes, minus 19 on 24 less than or equals to this. This will give 29 on the 24. Is that okay? Now we have to multiply all through by 2 so as to leave k here. So this implies I'll multiply all through by 2. So I'll have minus 19 on 24 times 2, k on 2 times 2 less than or equals to 29 on 24 times 2. Is that okay? Now you see that we are multiplying by a positive whole number, so there's no need of changing the inequality sign. So 2 here, 1 times 2 here, 12. So we're going to have k being strictly greater than k strictly greater than minus 19 on 12 less than or equals to 29 on the 12. Is that okay? Now let's put 19 divided by 12 was it? That's 1 point something. 19 divided by 12, that's 1.58. So we're going to have k strictly greater than minus 1.58 less than or equals to 29 divided by 12. 29 divided by 12, that's 2.42. 2.42. Okay, I said this number line thing, you are supposed to do it in your rough work. So let me put this number here. This is minus 1.58 and this is 2.42. So this is open and here it is what? Close. So the integers we are supposed to take must be inside here. Okay, if this is 0, what are the integers that are present here? The integers, we have 1 and we have 2. Is that okay? Now on this other side, this is already 1.58. So the only integer present here is what? Minus 1, because after this it is minus 2. So this implies you can still draw it in your exam sheet for the examiner to see this. You understand? So this implies your k will be equals to what? Yes, I'll advise you to always draw it inside your answer sheet. for the examiner to understand what you are doing. So k will be equals to what? Our integers, I start from this lowest one. So this will be minus 1, 0, 1, and 2. So those are the integers we are supposed to take. Okay. Now, so when k equals to minus 1, what is x? This is, remember that our x was this. Let me write it back here. It's minus 5 pi on 24 plus k pi on 2. Okay, very good. When k equals to minus 1, we're going to have minus 5 pi on 24 minus pi on 2. Is that okay? So this will be equals to, we're going to have 24 divided by this one, minus 5 pi. 24 divided by this is 12, minus 12 pi. So this will be equals to minus 17 pi on 24, minus 17 pi on 24. So that's the first thing. So that's the first one. When k equals to 0, what is x? X will be equals to, I substitute 0 here. So x will be equals to minus 5 pi on 24. Is that okay? When k is equals to the next one, 1, x will be equals to minus 5 pi on 24. You substitute 1 here plus pi on 2. So this will be equals to 24. The LCM divided by this, I'm going to have minus 5 pi divided by this plus 12 pi. Is that okay? So this will be equals to 12 minus this will give 7 pi on 24. Very good. Then the last one, when k equals to 2, what is x? X will be equals to minus 5 pi on 24. I substitute my 2 here, so plus, this will give plus pi. Is that okay? Because the 2 will cancel with this. This will be equals to, we have 24. Because this times this will give 24. 24 minus this, I'll have 19. Yes, this will give 19 pi on 24. Is that okay? Okay, now we have already everything. So step 3, since there are no so the solution, wait, let me take the pen. So the solution, the solutions of the equation, so the solutions of the equations on minus pi are, the set of solutions will be, I'll take, the first one was minus 17 pi on 24. The next one was minus 5 pi on 24. The other one, 7 pi on 24. And the last one is 19 pi on 24. Is that okay? So we can then concrete the last step, because here there's no intersection to do, there is no union to do, because the other one was not having a solution. So step 3, solution on minus pi. So the solution to, so this is simply the conclusion step. The solution to our equation on So here, let me write this. The solutions, we simply write the solutions to our equation on the minus pi are s being equals to the set of solutions minus 17 pi on 24 minus 5 pi on 24, 7 pi on 24, and 19 pi on 24. So that's the solution. Is that okay? So we are going to do the last one. So I hope you understood everything. You first, when you are asked to find the solutions on an interval, you first find the solution, the general solution. That's the first step. After finding the general solution, you need to find the values of k for which you have solutions on minus pi, and from there, after finding the values of k, you deduce the corresponding values of x, of the angles that you are looking for. You conclude, and the last step, you have your conclusion. Is that okay? Always follow these steps for your work to be well organized. Okay, so you are going to do this last one. I'll be waiting for the solution. So let's dive into this question. So we're going to do, in the next video, we're going to solve the assignment you gave me. From here, there's no need for me to solve it even. You can easily solve it. You understand what I'm saying? But I will solve it for you to understand uh, things, for you to understand easily things. So don't just cram things, understand the logic, because you were unable to understand the solution that was in your textbook, concerning this question, this June question, because you did not master very well how to go about when solving trigonometric equations. You understand? So in the next video, we are going to see how to solve this question. See you in the next video.